Okay, when you're ready to buy your first telescope, it's best to do your homework. Always, if possible, go to your local astronomy club, and when they have a star party, check out the different designs, be it a reflector, refractor, or Catadioptrics, which are the mirror lens system. They have mirror lenses combinations, and see which one suits your purpose. By looking at them and touching them and talking to people, you'll get a much better idea. And then look at the different manufacturers. What's the differences between the various ones? Also, you can tell if there's any issues with them by actually looking and touching. And you can read reviews, but sometimes I have to ask myself, how honest are reviews in some of these astronomy magazines that when those same companies have full-page ads in the front and back, and now they're supposed to get an honest review. So always do the research for yourself, and then after using those, you should come to some consensus as to what would suit you. Also, before you order a telescope, find out what the return policy is. How long are you able to keep the telescope prior to having to return it? Do you need to have a return authorization number? Because the big thing is you're going to need enough time to evaluate the scope, especially optically. There's only so many days where you have good weather. So if you're working Monday through Friday, you don't really have time to use it, but you have clear skies. But then on the weekend, it's cloudy and raining. Well, you've wasted a week there. So that's important. Find out what the return policy is. And also, remember that everybody's opinions varies. What one person likes, the next may not. So look for yourself. As they say, beauty is in the eye of the beholder. When you're checking out these telescopes, is the mount steady? Be it a equatorial or Dobsonian? Are the motions smooth or are they jerky? A jerky mount will never, believe me, is very frustrating. Is the focuser smooth in its travel? When you're focusing in and out, the stars should come to a point. They should come to a focus. You shouldn't have to go back and forth wondering where is the sharpest focus. Do the optics pass a star test? Remember, the lens is the most important part of a telescope. If it is bad, nothing else matters. Also, when you're focusing, does the image shift back and forth? So when you're focusing in and out, the image should not shift, meaning, back and forth, top to bottom, whatever it may be. It should stay centered, and as you focus, it should come into focus and out of focus, but it shouldn't jump around as you go in and out. If it does, that means there's an issue with the focusing mechanism. So, and remember, high magnification is useless. So never buy a telescope that touts, 400 times, see Saturn's rings, because first off, you have to have good seeing, good optics, and if the conditions and optics don't allow, you're never going to be able to use 400 times. So just a few things to look at that I feel is important for the novice to do to get the most enjoyment out of the telescope that they do get. Okay, so I'm going to do a review here of this Meade Instruments Infinity 102 refractor telescope. I get people that'll ask me, well, what kind of a telescope should I buy? And there's so many different things to consider. Is it for an adult? Is it for a child? And possibly one of the biggest one is, how much do you want to spend? So I decided to purchase this from B&H Photo. They're out of New York. I paid $219.95 shipped, and I ordered it on a Wednesday and got it just yesterday on a Friday. So very good service. I will make a plug for B&H, and no, I'm not getting paid, but I've ordered stuff from them for years. I think they're one of the better ones out of New York to deal with, and so I just thought I'd mention that. But again, B&H is not paying me. I'm just saying that because I believe that to be my experience. Okay, so before we take it out of the box, this is the manufacturer's number 209 0.006. It is a 102 millimeter aperture. Okay, that's the diameter of the lens. It's an f5.9, that's the f ratio, which gives you 600 millimeters focal length. So before we go any further, let's just take a look at what those numbers mean. Okay, I said it was 102 millimeters of aperture. So what is that in inches? So what you want to do is take 102 and you divide that by 25.4. 25.4 is the exact factor you need to get the exact inches. Comes up to 4.015 inches and so on. So that's how you determine it's basically a 4-inch refractor. Now to the focal length. How do you know what the focal length is in millimeters? Again, in telescopes they use millimeters. So you would take 102 millimeters and you'd multiply that by the f5.9. Okay, so 102 millimeter diameter objective lens, which is the lens, and then you take that by the f ratio, 5.9, you get 601.8. They claim it's 600, close enough. So that gives you the 600 millimeter focal length, which is from the lens to where it focuses down at the eyepiece end. Okay, so it comes with an out-as mount. Now they're saying it's rock solid, steady, and for clear viewing. Well, we'll see about that. It's got slow motion controls, okay, which helps you, especially with an out-as, so it's not so jerky to get your altitude and azimuth as the object moves. And then it comes with 3 eyepieces, a modified achromat. You get a 23 times, a 67 times, and a 95 times eyepiece, which the focal lengths are, for the 23 would be the 26 millimeter, the 67 would be the 9 millimeter, and the 95 would be the 6.3 millimeter. Alright, so let's look at the math for the eyepieces. So how do you know if you've got a 26 millimeter eyepiece, what's the magnification? This goes for any telescope, no matter how expensive, cheap, it doesn't matter. This is how it works. So we know that there's a 600 millimeter focal length. So you take 600, you divide it by the focal length of the eyepiece. So in this case, we want to know what's a 26, 26, 23 times. Okay, now we're going to take the 600 and divide it by 9. That gives you the 66 times, rounds to 67. And then we're going to take the 600 and divide that by the 6.3, and we're going to get the 95.2. So that's how you get, that's how you figure what the magnification value is for any given eyepiece with the same telescope. Now the telescope came in this shipping box. Everything came in good order. I haven't opened it up yet. We're going to do it today in front of everybody here. So it did come in this box, and there's no outwardly damage to the interior box that holds the telescope. Okay, we've got the cover off. It looks like there's 3 independent boxes inside there. I would assume the tripod's closest, the telescope being the next longer box in the background, and then some eyepieces, miscellaneous stuff in the far upper left box. And it comes with some software that you see there. So you get a manual, and then you get some instructional DVD with some other stuff and software for the PC. Okay, looking at the top side before we pull the boxes, there is a little bit of, which I saw that on the cover of the box, a little something there. Shouldn't be any issue. Something went through to the outside in there. There's something here. So from this side, everything else looks fine. Just as I thought, the long box is the tripod, and you can see a little bit of that damage there. Looks a little worse there from the inside of the box. And it looks like we've got, oh, these are the knobs for the slow motion. And this is the center tray for the tripod. Okay, as suspected, everything is plastic. Okay, you got some metal there, and obviously for the 1/4-20 and some there, but a little plate here, but everything is plastic. Okay, all this stuff is just plastic. Down below for your spreader bars, that's plastic. By the way, that knob down there that holds the accessory tray that I'll be putting on, that's held captive, so that's nice, so you can't lose that. Here's the tray that goes down below. It's plastic, and it's threaded here. It is threaded plastic, no insert. So again, this is a plastic tray. And there we see the accessory tray. Those holes are to put your eyepieces in, and I guess those other notches that you see there and over there, I would think are probably, what you're not going to get with this. This is probably made for other setups, for a keypad. The holes you see there are going to be for putting your eyepieces. Now, I personally don't do that. I keep my eyepieces in a case, a separate case. When I need them, I pull them out. I do not like dust and dirt just collecting like they would just sitting there. But that's me, so I never use that feature. I would never do that to any of my... Oh, I neglected to say that the three legs, the down tubes there, those are a stainless. Those are a metal right there. I believe those are stainless. Everything else pretty much is plastic for the most part. Everything else is all plastic. But again, for the price point, I didn't expect it to be any different than what this is. And these are your control knobs that go on your azimuth and altitude, so that way you can turn them so that the motions aren't so jerky. And it just helps you to follow an object when it's moving across the sky. As you can see, you don't really need any tools to put it on. There's a flat on here, and you want to get that to where that screw sits on that flat. Now they both went on a little snug. There was, inside this hole, there were burrs from when they tapped that hole. When they tapped the hole here for that screw, there were burrs. So initially putting it on, it was a little snug. Once I overcame those burrs and broke them off, it went on fine. But as you can see, when I'm moving this, you see how that's moving. So that would move your altitude up higher. This would move your altitude lower. This turns your azimuth. You can see it's going to the left right now, counterclockwise. When I turn clockwise, it's going to the right. Okay, so this is the OTA, your optical tube assembly. This will contain the tube, the lens, which will be on this end. I can tell because it's bigger. And your focuser and such will be down on this end. Okay, so I took off the initial outer bubble wrap, and then there was a plastic sleeve over this, and then we have more bubble wrap on the telescope. So I'd say it was packed pretty dang well. So there it is, out of the all the wrappings. So here you see the dovetail plate attached to the tube. That's what's going to attach then to the tripod. Of course, this is your warning. Do not look at the sun. I guess people have to be told that. I don't know. Okay, so this is your focuser end. This is made out of some type of casting, probably an aluminum, some type of... It's not a plastic. The knobs on here are plastic. It is a rack and pinion. And it is greased. There is grease on there, so You want to be careful at night that you don't touch that part of it. Your high-end scopes don't have, they're greaseless. But anyways, so just be careful at night. You know, keep your hands away from the bottom part of that rack. You don't want to put grease on other things, yourself or eyepieces or in the telescope. Now it's got these two thumb screws down here that you can pull out the eyepiece adapter. This is for 1¼ inch. And as you can see, there's no brass ring. They just go into the dovetail of the adapter, which again at the price point is not surprising. That's the way they were going to do that. And then also on the focuser, this knob here, that knob right there is for tightening the focuser down. I suppose you could give it a little bit of drag, but it's got plenty on its own. I would use that just to lock down your focus if need be. And then this is where your eyepiece would go in. This pulls out pretty tight. So this is where your 1¼ inch eyepiece would go in right here. Now this is threaded. I'm not sure why. If it maybe draw tubes, extension tubes, maybe that's the purpose of that. I don't know. Excuse me. I've already got flecks of paint on me. Probably from in here. Now look at that. I don't know if you can see that black. Now look at that. From the inside. There again, guys. Okay, you get what you pay for. Okay. Shit like that's gonna get loose and go up on your lens inside. So, but this is what you get. I'm just trying to show you what you get. I wipe that off. So, and there's more on the inside. So, buyer beware. So let's take a look at that. The smallest box in there. It's going to have your eyepieces, diagonal. This is the red dot finder. Again, everything's plastic. And that's going to fit on here like this. And I'm not sure if you can loosen this up or not, but it's pretty damn loose. I'll have to take a look at that and see. Maybe that can be tightened up there. And this is going to be your diagonal, and I think they said it was an erecting one, so it would give you right and left. Yeah, this is only one, so I think this is gonna make things, because normally with an astronomical telescope everything's upside down. You don't worry about it. It's right, left, top, bottom. You don't really worry about it. I do have high-end image directors when I want to do terrestrial. I never use them for astronomical viewing. This thing is light. It's obviously plastic. So extremely light. Okay, so that'll go in here. Put that in there real quick. This way, when the telescope tube is pointed on an angle in the sky, you know, if you're 45, 80, you know, very high up, this allows you to look straight down while the tube is up on an angle, which makes it very efficient and pleasurable when you're viewing. You don't want to be down here looking up at a 45, 60, 80 degree angle. Okay, this is interesting. The 26 millimeter came in a box with no bolt, no plastic contained, you know, just in a box. This is the 26. This is the 6.3, and then this would be the 9 millimeter. The Barlow lens came in a thing there too. And I gotta tell you, from what I'm used to, this is just some very, very light stuff. It's going to be interesting viewing tonight, if it's clear, because I'm going to do a review of how it looks optically. But, you know, everything is just, I don't want to use, you know, dare I use the word junky, but that's just me. I'm not used to this kind of stuff. It's all plastic here, and this little band on here, it's, I don't know, it's joined together, so don't know how many elements that Barlow is. It doesn't look to be coated very well, so I can't say, but it's certainly not high-end, what I would regard high-end. Again, for the price, you're not going to get that. Let's take a look at the 26 millimeter folding eye cup. I'm not sure what the apparent field of view is on these. 26. Now, did they weld this together? I don't know how this, well, I guess it just pulls up. There we go. Okay, the 6.3 and the 9 millimeter. And look here, it's made in the United States. Oops, I'm sorry, that says China. So, from what I'm seeing so far, this is what I would expect. Cheap eyepieces. Okay, very cheap. Construction that is going to be very, very minimal, and but that's what you're going to get here for this kind of money. So I'm going to put an eyepiece in this. Now you see this is deforming. This is all plastic, and I don't know if you can tell, that's actually deforming. Now I'm going to take the 26 millimeter, put it in here, and let's move this around. Tighten this down. Now watch. See that gap open? Okay. Let me try to zoom in if it'll focus decent enough. I snug that down, that gap opens. So this is, again, plastic. That's what you're getting, plastic. Okay, you also get these tools. That's a screwdriver on it. So let's look at the 9 millimeter eyepiece. Okay, it has very, I'm not sure if this is like a 40-50 degree apparent field of view, but it isn't much. With my glasses on, you cannot and will not see the whole field of view. I have to take my glasses off and plaster this up to my eye to see the entire field of view. The field stop is ill-defined. It's not sharp at all, and there's nothing but extreme blue around the edges. I mean, just unbelievable amount of blue. I don't know. I can just tell you right now, this is going to be a shit eyepiece. Okay, I'm not sure what else to tell you. Alright, this is the 6.3 millimeter. The eye relief is better than the other, but with my glasses on, you're not going to see the whole field of view. With my glasses off, you've got to move your head just a little bit around to see the whole field of view. And the field stop is better defined than in the 9 millimeter. And there's a lot of yellow around the perimeter. So this is going to be another junk eyepiece. So this is the 26 millimeter. With your glasses on, you cannot see the whole field of view. You have to move your head around. When I take my glasses off, I definitely can see the entire field of view easily. So it still doesn't have a decent eye relief. The field stop is about the same as the 6.3. and there's a lot of blue, a lot of bluish purple around the perimeter. So again, this is going to be, we're going to classify this as a shut eyepiece, even before I use it. So this is the Barlow. Now, what a Barlow does, it says 2 times. So what a Barlow is supposed to do is, well, let me pull these back. Again, this is plastic housing with this metal sleeve, and I'll show you here. They've threaded this sleeve on here so that when you put it in the focuser, it probably doesn't chew into the plastic. So this is all plastic, the little metal sleeve that goes on. So what's supposed to happen is you put the eyepiece in here and it magnifies by 2 whatever the eyepiece. If the eyepiece is 50, it'd be 100 and so forth. So that's what you got here. Nothing special. I cannot perceive any coatings on here to speak of. But again, this is what you're going to get for the price. So here's the lens end of the tube assembly. I took the dew shield off. It just kind of fits over here. I don't think it's meant to be taken off. In fact, it isn't, but I just kind of pulled it off. It came off easy. You see the little screws here that probably hold the lens cell in. Nothing special. So here's the business end. Now you can see the foil spacers. It's right here. You can see the foil spacers. There's 3 of them. So that's probably, obviously it's an air spaced. I'm not even sure if it's glass. I'm going to assume it's glass. I'm not going to touch it. Don't know if it's plastic. But this is what's interesting. I don't know if it'll show on here. I don't know if you can see that moving. I don't know. Oh, well, okay, there we go. So this is some kind of a retainer. Oh, shit. There we go. That's for the freaking lens. All right, well, let's just see. We're not going to do anything else here. That is plastic. Look at that, boys and girls. All plastic. Okay, then we're not going to move anything. You can see, again, it's a plastic lens cell. See where the glass is. Let me screw that back in. No need to. You can see. There we go. Now you don't want that. I don't know what they have. You probably don't want that too tight, but I don't know, because you don't want to pinch optics, but it doesn't leave much. I'll have to check to see if that rattles, if they left it. Just like that. And this is the dew shield. It just fits. There we go. This is the lens cap. Again, plastic. So one thing I noticed here, here's the handle for the altitude. Now, right now the tube is in between the 2 legs here, but it's going to hit your slow motion control knob, and if I go all the way down, okay, it will go somewhat, it won't go 90 degrees from what I'm seeing here, but it goes fairly up. It won't go all the way to the zenith. Now, this thing moves pretty damn tight. Now look at the flexure in that. I don't know if you can see this moving. Let me tighten this down. I mean, look at the sway in the legs. Okay, but again, I don't expect much different. Let me loosen up the azimuth lock here. Now, if the telescope, if you had it set up and you were looking at something, obviously it's going to hit here, so you'd have to constantly rotate the tripod if you're going to look at something at much more of an angle, because otherwise it's going to hit here. Now this moves really tight. I suppose I could loosen that up very, very tight. I mean, you can just see, and here's going to be part of the problem. You're using, say, I think, what was it, 93 time eyepiece, and you're moving it. Now you see the flexure. I haven't even moved. The telescope has not moved here. All I'm doing is flexing the unit. See it flexing? So as I go to move it, right now, guaranteed the object's going to be out of the field of view, whether you're looking at a planet or a star. And then you're going to have to overcome the friction, which is tight. You're going to go, then it's going to go way past what you need. Then you're going to want to come down. It's very, very jerky. I may try to loosen this and see if I can make those motions better. But you see what I'm saying? So now you're trying to get it in the field of view, because you initially got to move this around manually. Okay, you get it where you want it, if you can. Okay, you get it where you want it, and then obviously you're going to be using this. But if you need to make any, getting it there first is going to be the issue, because it's very, very jerky, and you got all this play, all that play. See the tripod? But again, just want to show you what the pitfalls are. Now this may be okay to you, so I'm just showing you what I see as issues. It may not be to you. Beauty is in the eye of the beholder, as they say. So here's something else you're going to need to do. When you go to a new object, okay, kind of put it like that, and then as you turn it clockwise, because that's going to be moving in the direction that the rotation of the Earth, which would be towards the west, as the stars apparently move to the west, because there is no means to get this undone. If you go to your next object, okay, moving it manually like this, okay, then you won't be observing that long. At least you'll have more time, okay, because once this runs out of travel, and it gets way over here, as you can see, when it runs out of travel, I'd bring it all the way back here, and that way, as you start observing for the evening, gives you that plenty of time before it gets here to where you've got to come back here. Now that's in your azimuth control, which is measured on the horizontal plane. 0's north, 180 is south, well, 90 degrees is east, 180 is south, 270 is west. Now your altitude, which is this control, the up and down, the vertical, if you're on the west side of the meridian is your north-south line that goes from the north up to the zenith above you and back down to the south. If you're on the west side of that meridian, then you're going to want it like this, okay, with this threaded end closer to here, okay, as you see it, more threads down here, because as the object is now moving to the west, it's getting lower in the sky, so you're going to want to do this, and obviously the tube's going to go lower, as you see here. Now, if you're on the east side of the meridian, then you're going to want to put this over to this other side, because now the stars are rising, and so when you turn it counterclockwise as the stars are rising, now you will have this following. Now again, you're going to need you will need to use both controls here, okay? You've got to use both of these knobs, your altitude and azimuth. So you'll be turning both of these in conjunction, and it's just one of those things that you'll get a hang of it once you do it. So if the object is rising, you'll be turning this counterclockwise, and you'll be turning this clockwise if it's if you're in for the majority of the time. But again, you'll see once the object starts moving, you'll see which way to go, and this will make it better. This will make it easier to follow, especially since the motions on this is so damn jerky if you move it manually. Okay, so what I ended up doing here is taking a 19mm socket, okay, and I was able to work with the nut on here. It's got it's the nylock type. It looks like they've got a little blue Loctite on it, but by loosening it and then moving this up and down and just ever so slightly tightening it more and more until it had a better fluid motion. Okay, now you loosen it too much, you're not going to have, it's going to be too loose. So you got to reach that happy medium point where whatever you're comfortable with. So, and another thing is, it's looser here. When I get up here, it's tighter. Okay, now look at that flex. Look at the flex. Okay, this hasn't even moved yet. This is just before I overcome friction. Okay, so that's what I'm talking about. But if I go too loose, then this thing's going to be just too damn loose. So that's just something you've got to play with. Okay, because this is what you're going to need to do to get this lined up. Now the altitude isn't bad, or the azimuth. Okay, your horizontal plane, because you can kind of play with this knob over here, and it's not that bad. You can get that to be fairly fluid. That's not bad at all. Okay, it's this altitude head motion that it's very sticky. But again, 19mm socket, your ratchet wrench, just work this back and forth till you get it where it's not too loose. Again, if it's too damn loose, it's just going to flap and fall. But this hasn't even moved yet. This has not moved in this yoke. And look at the play. Look at the play in here. This is your tripod. So that's going to come out in the field of view at your eyepiece when you see things jumping around. So this is your red dot finder. I've never used one of these. I use a finder scope. This turns on this is the switch that turns on the red dot. The battery is in here. I haven't looked at the directions. I'm assuming you're going to pull these screws out. Probably, I'd have to look, but in any event, to change it. But this knob adjusts side to side, because you're going to need to, just like an optical finder scope, you need to align the plane of this to the optical plane of the telescope tube, the optics. So that's what you're doing. So this, when you turn this literally moves this side to side. Okay, this knob moves it up and down right here. Again, complete plastic construction. Put that in here, tighten it down. Now look at all the play in it. Obviously this is to get your object in the field of view. An optical finder is always best if you're not using a go-to mount or digital setting circles, but this should suffice to get you in the general area. Then you need the pan, but yeah, so that's what it is. It's just cheap. It's going to do that. Should work sufficient though for what you want to do. You're not going to be using high powers. And then down here you see I put an eyepiece in the tray, as I was talking about earlier. That's why those holes are there. If you want to keep an eyepiece in there. Okay, I'm not going to be able to show this by putting the camera to the eyepiece here, because it's not going to be anchored, and it wouldn't wouldn't show properly. But just like I said, with the amount of friction in this and looseness and slop, when you go to see, this shows it even better. See that? Look at all that slop in there. And it hasn't even moved yet. So what happens is, if I want to move this down, okay, now watch, now see if you can tell. As I push it down, now let's say, oh, it's in the eyepiece. When I let go, you see it flop back down. So now you got to make another adjustment. So it looks like you're going to have to get it close and then use your slow motion controls. Obviously a good azimuth mount will not do that. Wherever you put it, it's going to stay. Then you go to the slow motion controls. But again, I'm just trying to show you what you get for the $200 price point. So these are the pitfalls that you're gonna have. So the only motion that is actually relatively smooth is your azimuth. As I look in the eyepiece here, when I move it and stop, it stops. There's no settling in. You move it, it stops. Unlike the altitude, where now see, this isn't bad when you go up here. It's when it's at the lower angles that it's jerky. Once you get a little higher, it doesn't look to be so bad. But again, nothing that should not be expected from something like this. Just trying to show you what you're up against with the mount. The most important part of any telescope is going to be the optics, no matter what. You want good optics. Optics are your most important part. Second from that is going to be the mount. But if I had to spring for something, it'd be the optics first. Then you can always get a better mount. Remember, optics, then your mount, in that order. It'd be foolish to buy a high-end mount with piss-poor optics. So when you're going to buy a telescope, get good optics, save up your money if you have to, and then buy a better mount. In this case, we have neither. But we're going to test this out on the stars tonight. It should be clear, and I'll give you a report as to what I think about this the rest of the way. So I wanted to see what I could do to improve the motions of this altitude bearing part. It was just very sticky and not really good at all. So you have this nut that requires a 19mm socket and a ratchet. I took this off, and what you have is a heavy steel washer and a plastic nylon type washer that's up against this casting. But what you had before this was this lock washer. I thought, well, let me try something. So I took the lock washer out, put this back together with the plastic washer up against this casting, and then the steel washer, flat washer, then put the nylon nut on there. Now, as you can see on this side, on both sides of the inner part, you have this plastic nylon bushing on both sides here and here. Then you also have on this side, you have the up against the casting, you have that same plastic nylon type washer and then a steel washer behind it. So all I really did was take out the lock washer that you see here, and then just take your socket and ratchet, and then you just carefully, what I did is I tightened it down, and then I kept moving this up and down, and then just started loosening it until it just got the right, what I thought was the right amount for me. And I'll tell you, it works a whole hell of a lot better just like that. So something else I did is I rotated this handle, and you'll need a 13mm open end wrench, and you get in here and you back it down, because this acts as a jam nut. And then with the telescope off, then I rotated this counterclockwise, one rotation. Then I put the scope back on, and then I put the handle just so it's a little bit away from the focusing knob, and tightened it back up, jammed it, took and tightened it, jammed it up against this casting. And actually I find it to be more out of the way than when it was in the position of coming out and then down. But that was just a personal preference. I just thought I'd share that with you. That's one of the things. Again, just trying to tweak this. Now one thing, it's still choppy now, so it's still not perfect. Okay, I mean, there's still going to be, when you're moving it, it's still, especially up, more so when it's up, when you're pushing it, lowering it in altitude and let go of it, see how it drops? I couldn't do anything with that. Part of that is also in here, just in this, in all that there. But at least it's, I feel, the unit that I have here, the scope and mount, is a little bit better than what it was. Okay, I thought it'd be interesting to show you the difference between just what you get when you buy things when it comes to optics. Now on the right is the 6.3 millimeter that comes with this telescope. Here is a 6 millimeter Radian. Now this is the cheapest eyepiece I have. TeleVue no longer makes the Radian series, but I have every one that they've had. I've got the full set. So here's a 6 millimeter Radian, 6.3 millimeter. Look at the difference. This is why this eyepiece costs $240 more than this whole telescope setup. Okay, this 6 millimeter Radian was $240. This whole telescope mount and 3 eyepieces in Barlow were what, $219.95. So, but look at the difference in design. This is going to have a long eye relief. You can use your eyeglasses with this. You can adjust the eye cup. It's a beautiful eyepiece. Inch and a quarter. Okay. It just kind of shows you that when it comes to optics, you get what you pay for. Okay, we're going to do the same thing with the Barlow. This is a TeleVue 2.5 times. This is the 2-time Barlow that came with the telescope. This Barlow's $218. Okay, the cost of this whole telescope. Again, there's a reason why things cost, and when it comes to optics, sometimes you got to pay the money. But I'm just trying to show that you don't get much for $220 when you're getting a whole scope and mount. Okay, so there you can see the red dot. Obviously it's not in focus because the camera's not focusing on it, but and you can't see the moon. There, it's off. And I've got the rheostat here turning it, and it's brighter. If it was darker, you'd probably see it better. But the problem is, these adjustments here, as you go to adjust this for altitude up and down, and then you've got your side to side over here. As you turn this has so much wobble in it that it just dances side to side. It's not rigid enough to where when you make these adjustments up and down, it literally just, you know, since it's not rigid, it's just really useless. It's very hard to use. Extremely. Okay, now that it's a little darker, you can see the moon in there and the red dot. And when you go, like I said, when you go to adjust these, I don't know, it moves around. It's almost futile to even try to line it up because it just doesn't stay. You think you got it adjusted and you got to tweak it back the other direction, and it just shifts the other way, and then it's just back and forth, back and forth. So as far as I'm concerned, with all the play in this red dot finder, it's just not very good at all. It's not rigid enough to really do its job, in my opinion. I'm not sure how well this will show up. I'm just holding this camera at the 26mm eyepiece, and I'm focusing through the viewfinder here. Let me see if I can bring the moon. I think that looks about right. I don't know. Let's see here. It's kind of hard to focus on the screen. And it's hard to hold this camera steady just holding it at the eyepiece. Using the slow motions here to move it back and forth. Okay, I'm just moving this by hand now. This is the I forget what eyepiece this is. And again, this may not work out too well. I'm just holding the camera up to the eyepiece. Again, with all that backlash, when you're moving this a little bit up and down, it just doesn't want to stay where you put it. You got to kind of screw around with this thing, with the mount. So let's see what eyepiece this is. This is the 9mm, and we're just looking down into the diagonal here with the moon in there. That's all. The eyepiece is out. Okay, so the moon that we were looking at here, I'm just looking on my phone, an app, Phases of the Moon, Saturday, August the 18th, 2018. Right around the 9 p.m. Eastern Standard Time. And so this is the phase of the moon that we were looking at. And it was 50% illuminated, and at this point in time it's approximately 243,649 miles away, and in the constellation Scorpius, moving into Sagittarius. And it is moving away, as you can see the count there. Moving further away. So I just wanted to show this just so that you could see what we were looking at in the eyepiece. Okay, so what did I think of this telescope as a whole? Well, I believe the video speaks for itself as to any issues that there may or may not be with the scope. And again, that shows the issues that I did have. You can make up your own judgment as to that. The quality, optically, I was pleasantly surprised with the moon. Last night I was able to look at the first quarter moon, and in the 26mm, really gave a nice view. There was false color around the limb, which was to be expected. That's in a two-lens system, but nothing very bad. Even on the bright stars, it isn't that bad. I mean, you do get some false color, but nothing that is horrendous. The 26 was my favorite eyepiece because it gave the brightest field. Okay, it was brighter, obviously less magnification. The 9 on the moon was okay also, not bad. The 6.3 was terrible. It's got a very dim field of view. It's very narrow. With the mount the way it is, it's hard to keep it in there. It was just, didn't like it at all. Didn't even use this on the stars. In fact, I didn't even use the 9 on the stars either. I stuck to the 26, mainly because it gave the brightest image, and with the mount being the way it was easiest to control with the wider field of view. My suggestion is, if you're going to use like the 9 or 6.3, put the 26 in first, get it centered, and then pull it out, put the 9 right back in, or the 6.3, so it's somewhat in the center, and then focus. Oh, also the Barlow, I did not even use the Barlow. Wasn't even going to use it. Didn't even have any inclination to want to try that, so I didn't. Just used these 3 eyepieces alone that came with it. So the moon, like I said, was fairly decent. So I was very surprised. And now to the stars, this morning I got up early. Wasn't too bad, wasn't perfect, but I did look at a few, just to look at the stars, the focus. I looked at the Pleiades, again, with the 26. It was an enjoyable field of view. I didn't even try these, didn't even try the 9 or the 6.3, just wasn't. Again, because of the mount. But not bad. And the brighter stars obviously had a little bit of color. The dim ones, you didn't even see anything. So I wasn't able to see any of the planets though, so because of didn't get around to it. Don't really know that I need to. I think, you know, it is what it is with this scope. But I will say the mount is the weakest link here. The mount really made the scope less enjoyable to use. It was a real pain. Okay, so the mount really, again, in my opinion, limited you to what you could do, and it was just a pain, just a complete pain, which is a shame. And again, I tried to make it better, as you saw, and you know, you can only go so far. So that's about all you can do. So well, would I recommend this? Well, I guess for a child, a novice getting into it, you obviously don't want to spend a lot of money. This was $220. So if you're getting a youngster a telescope, you don't even know whether it's going to be something he's going to be interested in. You don't want to spend a lot of money. And I think this would be an excellent scope for, you know, 8, 10, 12-year-old that might have some interest in the stars, and a good starter scope. Again, understanding the mount. So, and just if they just use the wider field of view as they start to learn the scope, learn the sky, that would be the better thing. So again, I think that it'd be excellent for a youngster. Now, as to an adult, well, I don't know. I wouldn't recommend it. If somebody said, hey, you know, I want to get into the hobby, I'd like to buy a telescope, what do you recommend? I couldn't recommend this, just because it was, again, because of the mount. And I just think an adult would get too frustrated and wouldn't want to use this thing, because it's just, again, the mount takes away from the enjoyment of the scope, in my opinion. So I think this would be a great starter scope for somebody young. And you know, for $220, you really can't go wrong.